So we have a standard deviation problem. And with standard deviation on the SAT, you do not need to know how to calculate it per se. You do need to just understand how it kind of works. So standard deviation is the measure of how spread out the data is. It's called a measure of spread. It really is just the kind of the average distance that each point is from the middle. So so we want to first be able to figure out the relationship between the means and standard deviations, but we don't want to have to do any actual calculations. So first, the means. Well, if you look at set 2, there is a lot higher values, right? There's way more 6s and 7s and 5s than there are here, and this one has a lot of lower values, more 2s, 3s, and 4s. So something that has higher values is just going to have a higher mean. So if we look at how the means are related, it says set 1 is less than set 2. So that makes sense for now. Here, the mean of set 1 is greater. That doesn't make any sense. The mean of set 1 is less than. Okay, so that still makes sense. And the mean of set 1 is greater than. So I get rid of those. So now we're down to just comparing their standard deviation. So here is kind of the idea. This actually, I believe I have this wrong. This is supposed to be a level 3 problem. So now what I have to do is kind of look at how the data is spread. But these two have the exact same spread. Now one is right skewed and this one's left skewed and this is right skewed. But they're opposites, but they're spread out the exact same way. All right. So what's going to end up happening is the standard deviations are going to be equal to each other. So the mean of this one is going to be higher, but the way since they're exactly the same layout, like one of these 2, 2, 3, 4, and 3, this is the same, and they're the exact same values. So the mean of set 2 is going to be greater than the mean of set 1, but the distance that all the values are from that mean are always going to be exactly the same. So you're going to have the exact same standard deviation. Okay.